Now that we've talked about some of the many operators in a Flux, we talked about factory methods, transforming operations, combining operations and action operations. Let's talk about how we get all the wheels to start moving, and that's something called terminal operations, or terminal operators. And you'll see that terminal operators sort of play two roles. One thing is they trigger everything else, because nothing runs until they're reached. And then they also do something, and most notably, they give a means to be able to handle on next, on air, and on completion events as they percolate out of the stream from publisher to subscriber. So the way you do this is called subscribe. It's a core operator. It's very important to understand because nothing works without subscribe in one way or another with reactive programming. And the subscribe method has a whole bunch of, or operator has a whole bunch of different method implementations. We're just going to talk about the most common one, or one of the most common ones. And this method is going to subscribe a consumer to this Flux, or subscribe a bunch of consumers and runnables to this Flux. So what this operator does is it consumes all the elements in the sequence. This is the first parameter. That's the consumer, first consumer. Handles any errors. That's the error consumer. And reacts to completion. That's the complete consumer, which oddly enough is a runnable, but leave that aside. Now, this particular way of doing subscribe requests unbounded demand. So unbounded demand is just a fancy way of saying that it wants the publisher to send data as fast as the publisher feels like, and it says, I promise to keep up somehow. If you don't like that, then you can use other techniques that involve back pressure. But by default, this particular subscription request will result in unbounded demand. Now, remember there's a little regular expression, which is probably a good quiz question to have you explain, which is how are the signals emitted? And they're emitted according to this little regular expression, which basically says there can be zero or infinite number, zero or more number of on-next calls, optionally followed by either on complete or on error. And of course, if you're perplexed as to how to read this regular expression, what is the solution you should immediately go to? ChatGPT. You could do the regular expression 101 too if you wanted to. That would probably take you a lot longer. But you'd be much more broad in your knowledge, which is good too. OK, so that's how we can understand how these things are emitted and how they end up coming through the subscribe method. So it may turn out that nothing comes through. It may turn out that an infinite number of things come through the on-next consumer, or an error could occur after some number, including zero, on next calls, or on complete could be called. So there's a bunch of options. So what is returned from subscribe is something called a disposable, which is actually somewhat annoying in various situations. We'll talk more about that later when we get into some examples. But a disposable basically is an indicia, it's an indicator that a task or a resource can be canceled or disposed. So it basically says, this is something that I'll get back and I can store, and when all is done, I should get rid of it because it'll free up any resources related to that particular stream that's being used. One cool thing you can do with disposables is you can accumulate them and dispose of them in one fell swoop. So here we have a disposable composite, and we can register a bunch of schedulers or subscribers and so on with this thing. And when we're all done with the program, we can get rid of them once and for all. Now, the other thing to remember about subscribe is nothing works until subscribe is reached, or something that wraps subscribe. Very, very much like in Java streams, nothing is reached until a terminal operation is encountered. And now the main difference is there's a range of terminal operators in streams. You've got collect, you've got reduce, you've got a whole bunch of other things you can use, for each and so on. And in the world of reactive programming, it's got to be subscribe or something that calls subscribe. So let's take a look at an example. Here we're going to have a big fraction list, and we're going to multiply and reduce, or so we're going to multiply these big fractions by some constant. And then we're going to subscribe, and that's going to set the wheels in motion. It's like the green flag at an auto race. And then if it all goes well, we'll get on next events here, and we're going to basically append them to a string builder. If something goes wrong, then we're going to go ahead and append an error message of some kind. I kind of left some details out here. And when we're all done and everything succeeds, we're going to go ahead and display the results as a string. So that's just showing the 3 different kinds of results. Now, if you don't care about errors, if you don't care about incomplete, then you can just go ahead and do this. And there's various overloaded methods of subscribe that will let you do that kind of stuff. How? Now, here's a very important thing to remember, and this will perplex you at first, and it still flummoxes me from time to time because it's a little bit annoying. Calling this method will not block the caller thread. Now, for synchronous processing, it doesn't really matter because you're not going anywhere until you're done, so no big deal. But for asynchronous processing, you've got to be careful because subscribe will return right away, and if the caller thread ends up exiting the whole user thread, and there's no more user threads left over, then the program will shut down. And that's very perplexing. So it's designed this way with a purpose because they're really trying to emphasize fully asynchronous programs, and lots of places that works just fine. But there are situations, particularly for testing, where this can be a little annoying. And that's why we're going to have the mechanisms we talk about, like the async task barrier framework, to allow all this stuff to be running asynchronously, but not have the main thread of control fall off the end and cause the program to shut down. So remember that. There's no direct way of being able to block on subscribe. There are other versions of subscribe that support different capabilities. For example, there's this version here where you can pass a custom consumer that will do some cool things like apply back pressure and other interesting features. We'll take a look later in the class, not right away, but later in the class about how to use this. It's kind of neat and gives you more power and more flexibility. RxJava also has a subscribe operation that works just like the one in Project Reactor. One thing they do have, which is kind of cool for testing purposes, they also have a blocking subscribe operator in RxJava, which will block until everything's done, which is very helpful when you're testing your programs. So that's the end of the overview of key terminal operators in the Flux class.